Hi, I'm Judy Lewis at Vanderbilt University Medical Center, and today I'd like to share the reproducible workflow that my colleagues and I here at Vanderbilt and also at the City University of New York have developed for checking and aggregating observational HIV data for an online dashboard. Online dashboards have proven to be really valuable tools for gaining insights about population health metrics and for disseminating data. Our colleagues at City University of New York saw the need for an interactive dashboard that displays HIV outcomes before and after the World Health Organization recommended in 2015 universal treatment of all people living with HIV, regardless of CD4 count or disease stage. This treatment recommendation, also known as Treat All, has dramatically improved access to life-saving treatments all around the globe. Of course, we needed a source of data for this dashboard. The sub-Saharan African regions of the IDEA network have data on over 1 million patients before and after the Treat All guideline was implemented there. But first, what is IDEA? Well, IDEA, or the International Epidemiology Databases to Evaluate AIDS, is an international HIV research consortium established by the United States National Institutes of Health in 2005. IDEA was designed to be a federated network, meaning that regional data managers collect and map data to the IDEA Common Data Model, and then share data sets only when requested for approved research concept projects. So there's no central database in IDEA, and these data are only shared, the subsets of data that are requested are shared for approved projects. So now we have a source of data for our dashboard, but a number of challenges stood in the way of getting that data from these hundreds of clinics, which of course represent information in a wide variety of ways, to a form that could be used for the dashboard. First of all, for data managers, the process of gathering observational data from clinics and mapping the variables to the common data model is complex, time-consuming, and can inadvertently introduce errors. Data quality is very important, of course. The usefulness of the dashboard depends on the quality of the underlying data. The dashboard vision involved calculating extensive metrics from the raw observational data, and this is a complicated process. Pre-aggregating those metrics by country, age, and sex is necessary to protect the privacy of this patient-level data. So if the process of cleaning data and calculating metrics is too burdensome, it will affect the timeliness of dashboard visualizations. So we saw the need for a reproducible workflow for generating the aggregated details needed for the Treat All dashboard, as we call it, and a process that minimizes the burden on data managers and at the same time ensures transparency in data quality. So let's start by looking at how data harmonization is handled for other IDEA projects. Within IDEA, when a research project is approved, data managers collect the data from the clinics in their region, map it to the common data model, and upload these data sets to the Harmonist Data Toolkit. The Harmonist Data Toolkit is a web-based application developed using R and the R Shiny package and makes use of REDCap. REDCap is the publicly available electronic data capture platform. And for the toolkit, REDCap stores the research project information and common data model details, and those can be retrieved from REDCap into the application. The toolkit checks data sets for conformance to the data model and then performs other data quality checks, and then automatically generates reports that summarize the data set and its quality. If the user is satisfied with the quality of the data set after reviewing these data quality results, the fourth step of the application provides an option to transfer the data set along with its report to secure cloud storage where it can be retrieved by the investigator before automatically being deleted after 30 days. And this application has been in use within IDEA since 2019 and has been really well received. So our solution for the dashboard data workflow is to simply add scripts that calculate and aggregate the metrics of interest for the dashboard into this existing familiar toolkit application. This ensures transparency of data quality. The toolkit calculates the aggregate data. These new scripts we've added to the toolkit calculate this aggregate data for the dashboard and then stores the resulting files in a new REDCap project using the REDCap application program interface. And then those files can be retrieved for the dashboard website. The metrics for the dashboard were determined by Dennis Nash, Ellen Brazier, and Ben Katz, who are IDEA investigators from the Central Africa region. Then I implemented the logic in R to calculate those metrics and aggregate them by every combination of country, age group, and sex. Those scripts are initiated only if a toolkit user chooses the treat all dashboard data request. So this isn't done for other IDEA research projects. The output of the R scripts is a total of 6 CSV files. These files contain the measures and outcomes for patients enrolling into HIV care and initiating ART therapy, the antiretroviral therapy for HIV. It includes CD4 count trends, and then there's a separate file for each of those that lists the number of clinics contributing data each year from each clinic. And from each country. Thanks to the REDCap application program interface, these files are stored, as I mentioned, along with data quality reports in a REDCap project. To give you an idea of the types of measures that are in these files, here's a description of some of the variables. This is just a screenshot that only shows some of the variables that we're calculating for the dashboard. And then now here you can see a snippet of the R code that calculates and aggregates those measures. And of course, this is a small screenshot of many, many more lines of code, but it's very efficient in a loop of that automatically aggregates for every combination of our stratification categorical variables of country, age group, and sex. Here's the design of the REDCap project that serves as a repository for these 6 aggregated dashboard data files that are produced by these scripts. And so also accompanying those files, of course, as I've mentioned, is the report that summarizes the data quality. In our initial use of using the toolkit for creating dashboard data, the toolkit processed 17 calendar years of data on well over 1 million patients from 21 countries in sub-Saharan Africa from these 4 IDEA regions. The time required for the toolkit to produce the aggregate data ranged from 2 minutes for the smallest of these 4 regions to 5 minutes for the region with over 800,000 patients. So these are some of the results, but the real result is the actual end product, the recently released IDEA dashboard, which is now publicly available at ideadashboard.org. And as this tweet states, the dashboard is designed to be a useful resource for scientists and decision makers. And you can visit ideadashboard.org to learn more. And one benefit of our approach is that investigators determine new metrics of interest in assessing HIV treatment outcome. They can easily be added to the toolkit R code. So it makes it a very simple and reproducible workflow, even as new metrics of interest are added to this dashboard visualization. The automatically generated toolkit reports will always provide the data quality transparency we need for the dashboard. Aggregating data in advance not only prevents the storage of patient-level data on a dashboard web server, but it also improves dashboard performance, since everything has been pre-calculated for every combination of age group, sex, and country. And we can look at the dashboard really quickly to see what I mean by that. So here's ideadashboard.org. You can see the home page here. You can learn more about the data that is used in the dashboard, the countries and clinics in sub-Saharan Africa that contribute data. And then here's a little glimpse of some of the featured visualizations. You can see that in particular in East Africa, the treat all policy really increased the number or percent of patients who have initiated the antiretroviral therapy. And if we explore one of these visualizations, you can see how pre-aggregating the data really helps with the performance of the dashboard. It's not having to kind of slice and dice the data on the fly. It's already been pre-aggregated. You can see here, we could check a specific country, we could check have a different year, choose a different gender, and I've chosen, let's see, we'll pick a bigger country, but we can see here then, what percent of patients enrolled had a timely initiation of the antiretroviral therapy, what percent were virally suppressed at 6 months out. And we could choose let's choose the East Africa region, and we can see here in 2017 that of the patients who had a viral load measurement 6 months out, 78% had viral suppression. Whereas if we chose, let's say 2012, we had very few viral load measurements 6 months out, and we also not nearly as many had viral suppression. But show you that just to show how the pre-aggregating the data helps with the responsiveness of the dashboard. But it also protects the patient level data. You can visit the dashboard, of course, as I mentioned, at ideadashboard.org. And you can view my code on GitHub at www.github.com/idea, IEDEA/harmonist, or you can scan this QR code here. You can watch a demo of the toolkit application by visiting this link, dataharmonist.org/presentations/overview, or visit this QR code at the bottom left of the screen. We, of course, are grateful to all of our collaborators and our funders. And please contact me with any questions or feedback at judy.lewis@vumc.org. And again, here are the links to resources for code, for a demo of the toolkit, and to the dashboard, which is, again, publicly available. Thank you very much.